All right. We have opened up. Oh my goodness. There are a ton of people here for you, David.
Oh, great.
Whoa. We always kind of waffle back and forth, the week before Christmas time, holiday season. Are people going to be around? Are they going to want to come? I think you brought the people.
Oh, well, cool. Quick question.
Yeah.
Is there any way that I could add a background before we start?
Yeah, yeah. If you go to the camera and click the little um, arrow,
Oh, I see virtual background.
select virtual, yeah. All right, everyone. I'm gonna go through my little spiel here at the beginning so we can get on with our presentation. Welcome. Thank you for coming the middle of December. Um, you have come to the right place if you were hoping to see oh, nice background, David,
Cool.
presentation on high performance HVAC with David Richardson from the National Comfort Institute. Very excited to have his presentation here today. And if you haven't taken a webinar with us before, we have everybody on mute. It's the same today, but you can submit your questions at any time. Find that little questions icon somewhere on your browser, depending on which one you're using. Click it and send your question to us here in the background. If it's really urgent, I'll interrupt David. Otherwise, we're going to save most of them to the end. But submit it whenever you feel like, so you don't have to wait till the end. We're being recorded right now. As soon as the webinar ends, I'll try to get this up onto our website at Lighting Design Lab. Give me about a week. Although I'm going to be out next week, so I'm going to get this one up way quicker. And there's a little survey that pops up after the end in your browser. We really appreciate if you take the time to tell us how you liked this presentation, what you're hoping for from us in the future as we're developing the calendar for next year. There's also a little React icon, which I really appreciate when people use because you're all off camera, we can't see you. So that gives us a little feedback. Please don't hit the dislike button, please. No, you can if you're feeling it, but there's also a laugh, there's also a heart. Those ones are really appreciated. Coming up from the lab, we've got one event in the hopper, end of January. It's a part two of a heat pump water heater program that we had in October was the last one. We've got 5 different manufacturers coming on to talk to you about their products and what heat pump water heaters can do it's mostly residential, but small commercial too. And Trade Ally office hours, they are booked. Oh, okay. Um, Trade Ally office hours are booked for December, but in January they've got all 4 open. So visit these links when you get a copy of the slides later and book your time with City Light incentive colleagues. Now I have to find Len and put him. Len, are you available to come off mute and maybe even on your camera to just give a little spiel on the HVAC incentives before David starts presentation?
I can. Can you hear me?
I can hear you.
Okay. The camera still seems to be a little bit wonky. Oh, there we
Nope,
go.
there we go.
Okay. And then how do we go about sharing?
I've got the slide up. So if you can see the
Oh, there it is.
presentation,
Perfect.
yep.
Okay. Yeah, already gave that to you. Okay. Good morning, everybody. My name is Len Canapel. I'm an energy management analyst for Seattle City Light. I've been here about 11 years, working a lot of commercial retrofit lighting projects and increasingly HVAC type things. And that's why you guys are here. So, do not pass up the opportunity to get an incentive for doing a energy efficiency upgrade. We have two different types of programs. One is a midstream, and that's distributor level where you want to buy a piece of equipment, and then you can go out there and buy this equipment, get an instant discount from participating distributors. Done. You don't need to go through an incentive contract or anything else with Seattle City Light. We also have downstream programs, and those typically pay 36 cents per kilowatt hour saved. That's a lot of different types of equipment, including the one you see in the picture. This is at a brewery. There were some pressure set points that were modified. Took a whopping 15 minutes to do and saved 360,000 kilowatt hours a year. So I would not pass up opportunities like this when the energy efficiency uh, program that we have is out there to help you get your project started, save some money, and make a better working environment for everyone. To figure out how to get started on these kinds of projects, whether it's domestic water pumps, chiller upgrades, adding VFDs to condenser fans, just start with our energy advisors. I believe all these links are going to be live, but the energy advisors, they do a great job of directing traffic. So they may not have the answers to everything, but they can direct you to people like us who do have the answers. And if we don't know, we're going to work with you to find out. So that's pretty much it. Just wanted to make sure all this information is out there to make sure that you take advantage of our midstream and downstream HVAC programs. And back to you, Katie.
Cool. Thanks, Len. Energy advisors they know a lot. So they might even have your answers. And on top of the commercial industrial heat pump stuff, we do have residential heat pump rebates. They are a point of sale. They're through our midstream program, like the one I mentioned that had in the heat pump water heater training in January. Anyway, all right, on with the show. David, thank you for being here. I'm going to hand the reins over to you and take it away.
All right. We'll see if this works. Thank you for having me on, and we'll see if it shares.
Looks good.
All right, great. Thanks for allowing me on. For those of you that have chosen to take time out of your day to hang out with me and talk about high performance HVAC, thank you. I appreciate you being here. I will do my best to make sure that this is worth your time. Some of you may have heard the term high performance HVAC before and wondered what it was. We're going to get into that, talk about a little bit of the history of it, and some simple steps on how to apply it. We're not going to get into the how-to. That's a college course worth of technical content. But we are going to give you a path. You'll notice that path is an acronym, and it's also an analogy that we use to help contractors and HVAC professionals understand how to apply this into their businesses and a proven process to apply it into their companies and to teach their staff. I would encourage you, if you've got a smartphone, take a picture of that email address up there, because you may have questions that come in after the presentation. I'd be happy to answer any that I can. I am the Vice President of Training, National Comfort Institute. So we're thankful that we're with you today. Before I came on with National Comfort Institute back in 2010, I actually did this stuff as a contractor. And you're going to find out in just a little bit, it had a very special place in my family's company. So we've done this stuff. I'm not just a talking head. I've done this. I've gone through the valleys and been on the mountains. So I know that this audience, it sounds like a pretty good audience with us. So I hope I will do my best to take this to fit this content, to make it fit what your needs are. The presentation that I'm giving is going to be more residential examples, but the same concepts also apply for commercial systems. So don't think that this is just a residential only thing. With commercial, the scope expands quite a bit. So I do hope that you'll find something valuable out of this, and look for just one thing that you can take and use. I'll try to drop little gold nuggets along the way that you can take and actually go and use. So let's get started. As we talk about high performance, I would like to issue a kind of a word of warning and a caution as we get started. There's an old Russian proverb, and when translated to English, it says, if you chase two rabbits, you'll not catch either one. There's a lot of principles that tie into high performance HVAC. And if you try to do all these at once, you're going to end up frustrated. You're going to end up feeling lost, and you're going to feel like doing this is impossible. The path to high performance, I said this was an analogy, it's a journey. When you do this, you're playing the long game. And if you try to do it out of sequence, you're going to get lost along the way. Now, the reason that we usually don't start something is because we simply don't know what we're supposed to do. We get lost in the details, and a blanket of fog sets in. If any of you have ever driven in the fog, you know what I'm talking about. And this fog that sets in around us, it's a fog of confusion. It's a well-studied phenomenon in the researchers call uncertainty paralysis. Now, some of you may have been to the circus when you were children. You may have taken your children or grandchildren and notice that there's a lion tamer. Sitting atop a stool is a lion roaring at the lion tamer. And the lion tamer has a chair in his hand in addition to a whip in the side. And the chair is forced into the face of the lion, and the lion just freezes. It doesn't do anything. Some of you may have saw that and go, wow, that is really cool. Why? The lion could absolutely eat the lion tamer alive if he wanted to. But because that large cat, while he's sitting on the stool, he can't focus on all four legs at the same time. So what happens is he's paralyzed. Because he can't focus on one thing to do, he freezes. Many of you have heard of fight, flight, or freeze when it comes to a response in danger. We go through these, and this is the freeze response. We freeze. These four pillars of high performance HVAC that we're going to talk about today act as those four legs on a stool. And if you try to focus on all four of them at once, just like a cat does on a lion tamer stool, you will freeze. So we're going to break this down into one step at a time. And then we're also going to break it down into one application at a time. So that way you're not trying to chase four rabbits, because if you do, you're going to miss every single one of them. So I hope you guys enjoy this as we go along. One of the things I do want to focus on is defining what high performance HVAC is, giving you a little bit of a background on it. Some of you may have heard this term used. Thankfully, it is gaining in popularity over about the past 5 years. But what many people don't know is this concept has been around for a long time. NCI actually coined this, National Comfort Institute coined this back in the early 90s when they founded. Now, many people don't know the history of what high performance HVAC is. If you talk to multiple people, you will probably get if you talk to 10 people, you'll get 10 different responses. So what I want to do is make sure that we're all talking the same language and moving in the same direction as we're going forward on this path. Now, the roots of high performance HVAC are actually founded in commercial air balancing, which came into being back in the late 60s when mechanical engineers found that their designs did not function as they intended, as they were put into practice. They went out and they did measurements to prove and verify that their designs were either doing or not doing what they were supposed to, and then they would test, adjust, and balance those systems to make them perform as they intended. Rob Falk, one of the late founders of National Comfort Institute, actually came from the commercial air balancing industry. He brought air balancing into his family's company, and they started using those principles to solve issues. They also started to add BTUs, the way that we measure heat in the HVAC industry did this, and then started to apply building science principles. Those three cores took on high performance HVAC. Now, what high performance HVAC does is it actually focuses on the skills of the contractor, something that we've lost sight of, unfortunately, in the HVAC industry. So high performance HVAC, it's a culture or philosophy of doing HVAC the right way. In reality, the way that it should be done. It's a way of business that gets back to the principles of craftsmanship in the HVAC industry, where guys care about their work, they care about the results and their customers. So it's about doing the right thing and then proving it through measurements. What's interesting about this is it totally changes the game for any contractor who's willing to embrace this philosophy, because it gives them freedom from just focusing on equipment, which is a component, to focusing on their skills. So in a low price driven market that's focused on changing out boxes, it is differentiation. It empowers a company and their staff to prove that they do the best work. And on the flip side of that, to uncover the deficiencies in their competition's work. That's what's interesting. There's four pillars to this you're going to see that focus on comfort, efficiency, safety, and health, not necessarily in that order. It's not a yellow label plastered on the equipment that anybody can sell. It is customized results that a professional can prove in the field. There's no smoke and mirrors in high performance HVAC. You have to deliver. Measurements make the performance of a system visible. Now, for contractors who care, they thrive on this. But for contractors who are just trying to churn boxes and trying to move equipment, it is one of the most frightening things in the world, because it's accountability. Once you measure something, you have to do something with it. So this high performance HVAC approach It's actually challenging the status quo of the HVAC industry of just moving equipment. It looks totally beyond the equipment, and it recognizes the equipment's not the system. The equipment is part of the system that is custom built by every single individual contractor. And they will determine the true operating performance of that system far more than that yellow label on the equipment. And once they embrace that, it changes everything. And you'll never look at an HVAC system the same way. Remember, this applies to both residential and commercial. It's one of the most rewarding ways of doing work, I believe, that you could ever find when it comes to business. Now let's get into this concept a little bit more. Our layout for this, just to give you a preview, is we're going to talk about the problem in the HVAC industry, and there is a big one. So we're going to talk about the problem that high performance HVAC addresses. We're also going to talk about the path. And path is a set of skills that a contractor needs to embrace or master before they can become high performance. Now, some people will only choose to do a couple of these, and that's fine. The beauty of this is you can take it and you can make it fit however it best fits into your company. Some will progress farther than others. Remember, this is a journey, a path. Some people drive really fast, other people drive really slow. So you move at your own pace. You don't compare yourself against another company or another organization. You cannot compare your middle to someone else's beginning or your beginning to someone else's middle. You have to move at your own pace. But I will tell you, if you don't care and you don't believe in this philosophy as I'm presenting it, some of you may already understand this and know this. If you don't believe in it, you won't continue because you will run into obstacles. It's not easy. That's not why everybody doesn't always do it. But I will tell you, it's one of the most rewarding things in the world. I mentioned that I did this before we got into working for NCI back in 2010. Back in 2000, I was actually on my way out of the HVAC industry. I saw it as a dead end. I was sick and tired of our family getting sold out on jobs that somebody was doing $50 cheaper when we knew we did better work. I didn't have a way to prove it. At that time, I mentioned one of the late founders of NCI, Rob Falk. I met Rob, and I knew this is what we were missing. We had tried all the industry trends, everything that was new and trendy at that time, and we were missing something. And it was the path. The path is what we were missing. Our family company that was going bankrupt back in 2000 turned profit within a year, and we continued to turn year after year. We started to solve problems that we always thought were unsolvable. And we started finding out that the problem sometimes was actually us. So this path works. I've walked it. And I know some of you probably have as well, or on that path right now. So as we get through that, I think there's going to be a lot of aha moments as you continue on through this. After we talk about the path, we're also going to talk about the steps. These are the ways that you can apply this. There's 3 different ways you have to look at this. You need to look at it from your own personal perspective, because if you believe in this, you will be a champion for it. You will drive it. The second aspect of that is your companies, those that you work with. They will have to catch on to the vision that you have. And then thirdly, you have your customers. They will need to understand this in a way that you understand it. And you'll have to translate some very technical topics. So we'll give you some simple tips on how to do that as we progress forward. So we've got our problem. We've got the path to solve that. And then we've got the steps that you can use to apply it. So let's get started. First off, the problem. As we're talking about high performance HVAC, there must by effect also mean that there is low performance HVAC. Low performance HVAC is the problem. As we look at the house, many of you have probably heard this, the house is the system. The HVAC is more than the equipment. And unfortunately, back in the late 70s, our industry lost its way. We started focusing on efficiency ratings on equipment, and we took our eyes off of the skilled labor that's required, the craftsmanship that's needed to make sure that the equipment does what it's supposed to. When you take a piece of equipment that's rated in a laboratory environment and you move it into someone's basement or crawl space or attic, you've changed every variable that piece of equipment's rated under. And there is no way to account for that unless you measure. So to account for that, the manufacturers had to take account of what they could, and that was in a lab. So as I said earlier, the yellow label does not mean the efficiency of the equipment. So as we look at this, the system and the equipment are two very different things. So as we go through this, I do want to make sure we're talking the same language again. When I'm talking about HVAC equipment, I am talking about a heat pump, a gas furnace, whatever the product or the component is that delivers or removes heat from the building. When I'm talking about the system, I'm talking about what the contractor custom builds on every single job. It's unique to their installation. It's unique to how they turn this piece of equipment on, how they design it, how they install it, how they commission it, how they interact with the homeowner, which is the biggest X factor in any HVAC system. Consider this. Many times in an HVAC system, one of the largest problems can be the person that lives inside the HVAC system. Now, let me clarify this for a second. There's two sides of an HVAC system. There's the traditional side of the HVAC system, which is the equipment, the ductwork, the registers, and the grills. You've got your interconnecting refrigerant lines, your controls, your wiring, condensate tubing. I mean, you've got all the different pieces that make up the system that are field assembled. But you have a second side of the HVAC system. Consider this. An HVAC system is a closed loop. Supply air has to make it back to the return grills to be circulated by the blower in the HVAC system. The building is an extension of that duct system. It's the second side of the HVAC system. So you have a building side of the duct system and you have a traditional duct system. And it operates off the exact same principles. Just like a duct system needs to be airtight, it needs to be insulated correctly, it needs to be sized right, it needs dampers to control the air. Buildings operate off of the same principles. They need to be sealed tight, they need to be insulated correctly, and then you may be wondering where the doors come in. Those are your dampers. You can actually control airflow in and out of a room just by opening and closing doors. So these same principles, many of you may be talking with HVAC professionals, and you're going, why in the world don't they get that they need to look into building science? It's because they haven't connected it with what they do. They don't understand it. Many in our industry have load calculations forced down their throat, and they're like, why are we doing this? It has nothing to do with HVAC. And they're right. Load calculations have nothing to do with HVAC, but they have everything to do with HVAC. They're not making the building science tie-in. It's 100% building science. So as we look at this building side of the duct system, it has just as much of an impact on the occupants as the equipment does. So this holistic approach to high performance HVAC is where we have to keep in mind that there is more than the equipment that is going to affect the outcome. So if you're looking at efficiency ratings and assuming that they're going to happen in the field, you might be missing some things. So with high performance being the goal, and what high performance is typically if you can get measured performance of 88% or greater, and this is delivered into the conditioned space, that building side or customer side of the duct system, that's what they're experiencing. So think of it this way. I'm sure everybody on the call has probably Amazon Prime. If you have placed an order, Amazon has what they call fulfillment centers, and they will deliver the products from their fulfillment center to your home. Think about this. The equipment is the fulfillment center. It's a BTU fulfillment center, if you will. It has to do what it's supposed to do. It has to be sized correctly. It has to be installed correctly, charged correctly. Combustion needs to be set to where it's operating safely by manufacturer specs. That BTU fulfillment center has to do its job first. Next, you have the delivery route. So these, with Amazon, they have their delivery drivers. They're delivering their packages from the fulfillment center to your home. Well, the duct system is what's delivering the BTUs from the equipment into the building or the customer side of the duct system. That is the intended delivery location. If we're losing those BTUs in between, we've got a problem. Now, another way that you could look at this, because I know you guys have had Amazon packages that have not showed up, especially as we're moving into the holidays. Another way that you could look into this is having a pizza delivered to your house. When you buy it, the pizza comes 100%. But on a typical low performance duct system, if you have a 10-slice pizza, 4 of those slices have either been eaten or thrown out the window. So you're only getting 60% of the pizza that you paid for. This happens in HVAC every day across the country, but because we don't measure, we have no idea. This is one of the reasons why at NCI our mantra is if you don't test, you're just guessing. We want to make sure that we're testing. We're not guessing on these things, because guessing is what's got us into the low performance race to begin with. Now, for those of you that think I've done a job according to code, it's doing great, I would challenge that assumption unless you have measured. Because what we have found from field studies is that a code compliant system gets you a whopping 6% extra. Something to think about. But remember, unless you're measuring, you're just guessing. So our job is we're trying to get, now ideally, if we could, get 100%. If you can do that, and you can do it, you're rocking. Your systems rock. However, if you get within 88%, you're doing much better than 57. So this is our goal. We're trying to combat what's causing low performance HVAC to try to get to that high performance side. And this is where it's the solution. This is the solution to low performance HVAC. And it's a combination, if you didn't catch this, of craftsmanship plus measurement, because you can't hide from those measurements. If you mess up something, you have to do something with it. You can either ignore it or you can fix it and learn from it so it doesn't happen again. So you're testing, you're vetting your systems, you're making adjustments, and sometimes those adjustments are very small. Other times those adjustments are very large. You'll never know unless you measure. But with these different measurements, we're measuring not only at the equipment, we're measuring at the system. We're measuring what's happening inside the building. And there's different levels of this as we get into the application piece. Some professionals will go all the way. Others will just be happy making sure that the equipment is doing what it's supposed to. There's nothing wrong with that. That'll get us a lot farther than where we are now. So keep this concept in mind. High performance HVAC. We're making sure that the system is doing what it's supposed to do. We're not just looking at the equipment, we're looking at everything. And there are varying degrees of how to do that, but it's the craftsmanship of that contractor who's installing that system, plus measuring to prove and verify it. And that is revolutionary for so many people. I hope it is for you as well as we go through this. So let's talk about the path. For anyone who wants to start, who's like, this is awesome, I want to start doing high performance HVAC. What's the path? Where do I start? So just like you're driving down the road, you need a roadmap. And that's what this is. I mentioned acronyms and analogies. PATH is an acronym. The P stands for pressure, specifically static pressure, which is the lifeblood of an HVAC system. This is one of the foundations of HVAC system health and where we're going to start as we talk about this. The A, many of you probably have already guessed this, is airflow. Airflow is how that HVAC system breathes. It's the medium in a forced air unit that transfers the heating and cooling from the equipment into the conditioned space, and it has to be set correctly. So A is the airflow. T is temperature, and the main temperature that we're referring to here is dry bulb temperatures. Now, many HVAC professionals will measure this, but when you look at this path, it's a way that you combine it. Sometimes we get the path out of order, as we talked about earlier. They'll start measuring temperatures before they have any idea what the pressures of the airflow are. And unfortunately, it's easy to make assumptions with that. So the T is temperature, specifically dry bulb temperature. And finally, the H is heat. That is the outcome if we do it. We're either adding heat or we're removing heat from the building through either refrigerant circuit or through the combustion process of a furnace. Heat, BTUs, British thermal units, is how we're going to start calculating that. We have to make sure that it's right at that BTU fulfillment center first. Then we have to make sure that it's delivering at least 88% through the delivery route so that customer can be assured that they're getting what they're paid for. So it's pretty cool when you can take a design and then verify it through measurements and see how close you were. It's also an assurance policy for your customers. You're issuing them a craftsmanship receipt that they are getting what they paid for. And for our industry, the HVAC industry, you know, the National Comfort Institute is a training company, but I think we're more than that. I mean, so many times when we talk to them, they say, you guys changed the culture in our company. So we may do training, that's what we do, but we're actually a culture change company. And this is one of the things that we're trying to do is help an industry that has been so focused on a race to the bottom and low prices for so long to show them that there is another way, a better way that serves their customers. And this is it. So let's look at the path, because there are pillars for that. You'll notice that there's, of course, there's 4, but I only had room for 3. So you guys have to put the efficiency one up there. It's actually a byproduct. If you focus on safety, health, and comfort, you're going to find that the efficiency piece kind of takes care of itself. And many times indoor air quality will as well. Because these pillars of high performance HVAC, so many times we focus on efficiency as the first thing. When in reality, if we focused on these others first, it's just going to happen. Now, interestingly enough, I guarantee you, if you put yourselves and you looked through the eyes of a customer and you started asking them what makes the most sense for them, what means the most to them out of these pillars that we're talking about, most of them will focus on safety first. But many of us actually focus on the efficiency side first, which is a lot of times what people don't care about, unless you're paying astronomical bills. Most people, they want to make sure that their homes are safe. They want to make sure they're breathing healthy air. As HVAC professionals, we have a responsibility for that. If there's combustion equipment inside the building, we have a responsibility to make sure that it's firing correctly, that it's exhausting all the gases outside and they aren't spilling inside the conditioned space, that there's low-level carbon monoxide monitors that can protect that couple and that homeowner. So there's a big difference, if you don't know, between store-bought carbon monoxide alarms and low-level CO monitors. There is a big difference. Also, we get into the health standpoint, which is a great segue from carbon monoxide. It can also have to do with dust. That's one of the reasons I actually ended up doing this, was my own home, brand new home. We were, I'm going to say, in a month, and my wife comes to me and says, this is the dustiest house I've ever lived in. Brand new house. We have dust everywhere. You could run your finger across the top of our furniture and ball it up. And I had no idea where to even start. 4-inch media filter is clean. Return grills are clean, no signs of dust, but it's everywhere in our house, and we have all hardwood, so it shows up pretty quick. We were fighting a building problem. Our house was depressurized, and it's insulated with cellulose, so you can take a guess what was happening. Those cellulose fibers were being pulled in through any opening that existed between the wall cavities and the attic, and those heavy particulate were falling and settling on the ground. They never made it back to the HVAC system. And that surge, that challenge, is what helped me understand the health side. And then finally you get into the comfort, which is typically one of the biggest driving factors for many contractors, many homeowners, when they want to solve these things, is a comfort issue. They're trying to figure out, why is this room too hot? Why is this room too cold? Why is this drafty? And high performance HVAC is one of those pillars that will help solve that. So with comfort, many of you may have noticed, or some of you may even fallen victim to this. I know we did. Trying to fix one of these problems with just equipment alone, and you'll fail, because you have to look at the system as a whole. And this is one of the pillars that we really want to focus on, because that is the one that typically promotes the most decision making from a customer. As we talked about this being a journey, think about each of these steps being a stop, or you could just say an exit ramp along the road to high performance. And that first stop, as we said, was pressure, static pressure. As we continue along down the path, we'll notice that airflow is that second stop. Temperature is the third stop. And then, of course, heat, or BTUs, is going to be the third stop. Many contractors will stop at the pressure exit. That's all they'll do when it comes to high performance. They're going to be perfectly happy measuring static pressure on a system, using it to determine restrictions, and using it to help their customers upgrade their ducts. They won't go any farther measuring airflow, temperature, BTUs. Others, however, will continue to go on down the path, and they'll start to add in airflow. Now notice, if you want to succeed at high performance, you need to have all these principles mastered. Because I will tell you, if you cherry pick which exit that you get off of, you may end up with very inconclusive results, because you don't have enough information to form a complete picture. So it's kind of like looking at just a couple of feet in front of you when you're driving, and you're driving 70 miles an hour, and all of a sudden there's a real sharp turn. If you don't look out on ahead, you may end up in danger. So with this, I would issue that warning as well. Remember, if you chase 2 rabbits, you're not going to catch either of them. Think about each of these exit ramps. They build sequentially on one another to get you to final goal. And ultimately that goal keeps growing. So as we go through these paths Acronyms. Pressure, typically there's going to be 4 different measurements. And static pressure is measured in inches of water column. Some of you may be familiar with pascals. That's the measurement that we would actually use on the building side. I'll get into that in just a second. But we're going to measure static pressure using a manometer. And there's 2 different types of manometers that you can use. There's either analog, which are the old school type, commonly called a magnehelic, or you can use a digital manometer. And with manometers, you get what you pay for. If you try to get by with a cheaper manometer, then you're going to pay for that in precision. Now, for some, that may be fine. If you're just starting and you're like, I don't know where to begin, start with an entry model manometer. However, if you're like, you know what, I've been doing this, I want to look at what the best is, you can actually upgrade to a micromanometer, which is a high precision manometer, and use those to measure much more accurate pressures. So not all manometers are created the same. And when you're measuring static pressure, you're actually gaining access to the air side of the system. You're looking at the pressures to see what's happening. Now, most systems, you're going to take 4 pressure measurements. On the slide that you guys see there, we have an upflow air handler. So I know many of you are probably engaged in heat pump retrofits. So with an air handler, it's going to be crucial to that. You'll notice that there's 3 different measurements up there. There's actually 4. But the first one and the main one that we look at whenever we're measuring static pressure is total external. Total external static pressure actually represents the amount of pressure or resistance in the system that the blower and the equipment has to overcome to push and pull air through the system. Now, the 2 main things that the blower has to overcome are the internal coil, sometimes called an evaporator, and the air filter. Those are typically your 2 biggest pressure drops when it comes to overcoming that resistance. The others are the duct system. And the very top measurement you see of the total external measurement, that is actually a supply duct pressure measurement. And that can give you a pretty good indicator on how well sized the duct system is. So many times in our industry, people are going around and they're taking a duct slide calculator and they're measuring ducts and they're trying to see how much air they have. Well, that's assuming that the internal area of that duct is being used 100%. In less than 2 minutes, you can take a pressure reading in the supply plenum and the return plenum, where the air enters the air filter, and you can determine if those duct systems are restricted or not. And then there's subsequent measurements that you can take to find those restrictions downstream. Earlier, you heard me mention that the static pressure or the blood pressure of an HVAC system, that's your total external static pressure measurement. It's easy to try to take total external static pressure and turn it into a silver bullet. In our industry, we are constantly chasing silver bullets. And I will tell you that this approach is not about silver bullets. Instead, it's about, if you're a hunter, you'll get this, it's about a silver shotgun shell. Because inside of that shotgun shell is a whole bunch of buckshot. That's the silver that we're after. It's all kinds of things that work right, packaged together. So it's not silver bullets, it's silver buckshot that we're looking for, packaged in that shell. So as we look at this, total external static pressure can easily be taken out of context. The easiest way to do that is if you ignore airflow. Static pressure without airflow needs to be taken very cautiously because you can make some very dangerous assumptions. So it is a great indicator, but you do need to keep moving down that path to get a little bit more information. So with total external, that's the blood pressure system. It can tell you if there's a problem. It will not tell you where. So I would encourage you, if you're taking notes, write this down. Total external static pressure can tell you that there's a problem. It won't tell you where. This is where you need the additional pressure measurements, the coil pressure drop, the filter pressure drop, and your duct pressures. What you're doing is you're essentially chasing high pressures. The higher the pressure, the greater the chances are that that component is restrictive to airflow. So essentially you're static pressure profiling a system. Now, I will tell you, some of you that are on this call that are HVAC professionals, you're probably going, I don't want my guys drilling in the equipment. And I completely get it. That is probably the biggest reading that scares people to death, because the most dreaded sound that you can ever have after you install test port in the equipment is to hear hissing from a busted refrigerant line. That's a bad day to be you. So there are ways that you can gain access to the system without risking damaging interior components. So there are ways that you can do that. There's a lot of different accessories that you can use. There's a nice flexible stainless steel static pressure tip that you can purchase. Our guys actually used to use basketball inflator needles in situations that they were scared about, because you can take a basketball inflator needle, stick it in the tube, and put it in an opening. It's not a true static pressure measurement, but it'll get you pretty close. So just something to keep in mind. But these measurements help us determine from the pressure of the system which components are most restrictive to airflow. Now, the challenge with air handlers is that there are two different types, and you cannot treat them the same. You have single piece air handlers, which are rated with the internal coil, and you have modular air handlers or two-piece air handlers, which are rated with the coil externally. So you may notice that total external. The easiest way to mess up static pressure is to take your measurements in the wrong spot. You're going to end up frustrated. You're going to start making assumptions about the wrong type of measurements, and you're going to end up missing a lot of stuff. This is one of the number one things that happened to us. We were taking in the wrong spots. So just to put total external in context, I want you guys to think about how the equipment, the air handling equipment, comes shipped from the manufacturer to the distributor. You have to look at what's as shipped in the box. Now, in a single piece air handler like we have pictured up here, the internal coil is included. It's internal. However, the return plenum that air handler is sitting on, the filter, the return duct system, return grills, the supply plenum, the supply duct, supply registers and boots, all of those are external. They're not included inside that piece of equipment as shipped from the manufacturer. So if you're ever wondering, well, where do I test? Keep in mind what's internal and what's external. External has not been accounted for by the manufacturer. Internal has. And that's why I say there's a big difference between an air handler measuring pressure and a gas furnace. They are rated very differently. That air handler, the manufacturer knows the internal pressure drop of it. They know what's included. However, with a gas furnace, it's rated completely different, because the only thing the manufacturer is accounting for internally is the blower. If it's a 90% condensing furnace, they're accounting for the secondary heat exchanger that sits above that blower and the primary heat exchanger. Everything else is external. So you'll notice that the test locations have changed a little bit. That internal coil was part of the external static pressure measurement before on an air handler. On a gas furnace, though, that coil is not part of the measurement. It's external, because that manufacturer of the furnace, and this applies to all manufacturers, they have no idea what coil the installing contractor is going to put on top of that furnace. So they have to rate it separately as an external coil. The filter and the ducts also apply the same way. So you'll notice that your test results change a little bit. Now, so many times you'll notice in these test locations that we're actually showing measuring the pressure before the coil in the furnace. And a lot of guys are going, wait a minute. The manufacturer showed drilling right in the center of that coil, what's called the delta plate. And I'm going to tell you that's the worst place that you can install a test port. Notice I'm not saying drilling holes. Now, drilling, that's what you do. You drill holes, but you never tell a customer that you drill a hole in their stuff. No one wants you drilling holes in their stuff. Words make a difference. So think about this. If you go to the doctor and they're taking your blood, they don't say, hey, I'm going to punch this needle the size of a horse's leg into your arm and suck blood out of your veins. They don't say that. They say you're going to feel a small prick. We're going to take your blood, and then you're done. Words make a difference. So don't tell your customers you're drilling holes in their equipment. They don't want you. But if you're installing a custom located test port to take the blood pressure of their HVAC system, that means a little bit more. That takes on a totally different meaning. So these do change, but I will tell you that that coil measurement's the one that scares most technicians to death. So if you're a contractor on this call and you're wondering, why can't I get my guys to measure? There's probably an unspoken fear that they're going to hit a component. So keep that in mind as you look at those test locations. But that pressure reveals everything about that system once you know airflow. But it'll start letting you know which component's the most restricted. And a lot of times guys will say, well, wait a minute, I've got a clean filter. Great. Is it sized correctly? We see that so commonly. You'll see in this photo, this illustration, there is a filter mounted, a 1-inch filter mounted right on the side of the furnace. And in many parts across the country, you'll see a 16 by 25 filter used on up to a 3-ton blower. Well, a 16 by 25 by 1 filter is lucky if it can handle a 2-ton unit, let alone 3. So if you're not paying special attention to your filter sizing and the types of filters that you're using, I would encourage you to dig into that. It's one of the easiest ways to relieve pressure on a system. Filters have killed more equipment than bad installations. It's an easy, simple solution if you pay attention to what type of filters you're using. Now, if you're using high MERV filters, great. Make sure that you got plenty of filter area for it, because air takes the path of least resistance. As we get into that, we're going to talk about some airflow rules. If air can't go through a filter, it will go around it. And if it can't go around it, it will pull through that filter eventually at a cost, and it will pull any of the particulate in the air through the media. So essentially, you are effectively derating the MERV value of that filter because of high filter phase velocities. The air is just moving too fast through it. Now, let's say that you measure high pressures on either the supply duct or the return duct. You can actually move downstream in the duct system and take 4 measurements every 4 feet. If you see a large change in pressure, it's a pretty good bet you've got a restriction in that side of the duct system. Now, the example that you see on the screen right now is showing a supply duct system. And you'll notice there's a big change between 0.13 and 0.03. In this example, it's duct liner that's come down internally inside the duct. Commercially, this could be a fire damper, but these pressures help us determine where the restriction is. Now, what's really wild is if you see a duct system that has turning vanes in it that have been installed improperly, measure the pressure drop across that. It's crazy what you'll see with this. Remember, don't guess, test, and you'll start to see these things. But you can even take a manometer and you can move downstream in a duct system to find out where the restrictions are. You can see this with transitions, with duct fittings, you name it. Your imagination with a lot of this stuff is going to be the limitation for how you apply it. So mastering these pressure principles is going to be the first stop on the path to high performance HVAC. The second is airflow. And you'll notice we're starting with airflow at the equipment. This is the best place to start. And there's a couple of ways to do this, depending on what you're willing to invest. So we'll talk about the simplest, easiest way to get started first, and then I'll tell you about the best way to get started about airflow. There are airflow requirements every piece of equipment has based on the capacity, both for heating and for cooling. Many contractors will use 400 CFM per ton. Others in humid climates use 350 per ton. And CFM, of course, is cubic feet per minute. That's a volumetric measurement we use for airflow. And it's an easy way to simplify it and kind of visualize it, just boxes of air. If you're in an arid climate, you need to move more air. And of course, elevation affects this as well. So you may be 450 CFM per ton or even greater as your elevation jumps up. So you're trying to move a certain volume of air to transfer heat from the equipment into the duct system. So you've got to make sure the air is right first at the equipment. So we start there. The simplest way that you can get started is once you've got those static pressure measurements nailed down, you can use a total external static pressure measurement and the manufacturer's fan table. Every manufacturer publishes fan tables for their equipment. Now, these work best when they're new. If the equipment is dirty, you're going to get some really goofy numbers, and I would not trust them. So brand new equipment, clean blower wheels with the manufacturer's blower motor, or at least a motor that matches those specifications, will give you the best results. So as you measure it, this is an estimate of fan airflow. So you can take your external static pressure measurement, you can take the manufacturer's fan table, and then you can actually plot that external static pressure measurement and the fan speed that system's operating on, and intersect the lines and see how much air that blower is moving. Now, it is an approximation, so just keep that in mind. It's an estimate, and it'll get you close. It's better than nothing or using the handometer to feel air blowing out of a supply register. Not the best. So this will get you close. So if you're brand new to airflow measurement, external static pressure and fan tables will get you started thinking in that direction. Air is the most important piece in our industry when it comes to performance, but it's the most misunderstood. Now, thankfully, over the past 10 years with the advent of the internet, social media coming together, the information is now out there, where it used to be you really had to go searching for it and sometimes pay a whole lot of money. Now it's easily available. So good for you guys. So with this air at the equipment, there's another way that you can actually measure it, a direct measuring device. The Energy Conservatory has a device called the Digital True Flow Grid. And it's an incredible piece of technology which fits in a filter slot. And it will actually tell you system airflow, or equipment airflow, I should say, when placed in a filter rack at the equipment. It's very versatile, but that is a measurement device. Now, granted, it's an investment, but it's a worthy one. And one of the things that we found is for salespeople that are trying to talk beyond the equipment and actually talk to a customer about their system and how it's affecting their comfort, health, safety, and also looking at the longevity of their new equipment, it is one of the best tools that I've ever seen. One of the things that pressure and airflow help you do as an HVAC contractor, if you're on this call, is make sure that you don't inherit somebody else's bad duct system. That's rule number one of going out and testing and doing any type of upgrades. You don't inherit another company's bad install. And this is just as common on multi-million-dollar McMansions as it is residential new construction tract housing. Most pricing is determined off the, or most HVAC installations are determined by lowest price, which means that the design has probably been run through and the lowest paid labor is responsible for putting that system in. Now, that's a brutal statement, but unfortunately it's fact in a lot of areas. It doesn't always hold true, but you need to be aware that if you go in on, say, a system that's 15 years old, you find the equipment's bad, and you pull out that existing piece of equipment and you put a new piece of equipment in from your company, you now own that previous duct system. Congratulations, because now you get the problems that accompany it. And so many times this could be prevented. So my encouragement to you is measure before you replace. It will save you a lot of headaches, because when you just replace that, you are inheriting those problems instead of letting the customer know, these are your problems. Let's look at how we can fix them together. And then you become an advocate for them to truly get what they're paying for. So the airflow equipment starts second. That's our second stop. As I said, you can use either a fan table, an external static pressure, or the digital true flow grid and get a direct measurement. It all depends on what you want to do. The key is to try to get these measurements, start to look at systems differently and look at this airflow piece, because it's the lifeblood of the HVAC equipment and the system. And the system's the second place that we measure, because you can have fan airflow that's exactly where it needs to be. However, if you have duct leakage, you'll notice there's a whole lot of blue arrows in that illustration. If you have duct leakage, then you have air that blower is circulating that's not making it to its intended destination. That's what the customer feels, that intended destination point. Now, you'll notice this is in a basement. Now, a lot of times guys will say, well, those ducts are in a basement. They don't need to be sealed. Really? Tell that to the most uncomfortable person in that home on the farthest end. They don't care that the air is leaking into the conditioned space. They care that their room is 4 degrees colder than the rest of the house, or 4 degrees hotter. That's what makes the difference for them. So we want to make sure that the air is making it from the equipment into each space. And of course, the only way you'll know how much air should go into each space is from a load calculation and equipment selection procedures. So you have to have the design values or your targets that you're aiming for as you go out and you start to look at these systems in the field. So airflow in 2 different places. 1 is at the equipment, 2 is at the system. Any difference between those 2 locations, you've got duct leakage. So notice how this is looking at things a little bit differently. Now, what's interesting is we transition into the temperature piece of this. A lot of guys measure pressure and airflow, and they're doing a really good job of that. But don't assume because you have pressure and airflow that you're going to have comfort. Most HVAC contractors that are going out running service calls today, I guarantee you the furnace or the heat pump was blowing air out of the vents, but it was room temperature. There was no process change, no phase change. They weren't adding heat into the building. And that's where we start to come into that third stop on our path to performance, and that's temperature. You have to have the temperature at the equipment. This means if it's a refrigerant charged unit, such as a heat pump or a straight cooling air conditioner, that refrigerant has to be charged correctly. Now, a lot of times guys will jump straight to that charge without verifying airflow first. Remember, if we start making assumptions and we start jumping to different points in the path, There's information that we're going to miss. So if you jump straight to temperature and refrigerant charge and you skip the pressure and the airflow piece, you're making a massive assumption about if that blower is set up correctly. A lot of companies think the blowers come set up out of the factory. They don't. You have to fine tune them and set them up correctly for the field application based on your design principles and data. So we want to make sure that the temperature is correct. So proper charging, proper airflow on a heat pump system. You'll notice that this is a gas furnace. So you have to make sure that the equipment is fired correctly, that you've got the right amount of input and the right amount of output. So also verifying combustion safety using a combustion analyzer. Don't assume because you set the gas pressure on a furnace at a certain setting that it's automatically safe. Instead, verify it with combustion numbers. Look for those. Make sure that that equipment is operating within specifications and it's safe. So start there. Once you've got the temperature at the equipment, you probably guessed we're moving into the second piece of this. Once you have it at the equipment, then you can move into the system. And this gets into those intended delivery outlets. Now let's go back to basements again, because you could have 100% perfectly sealed duct system, and if it's bare metal, still have comfort problems, because as we know, hot goes to cold. Well, if you have 130-degree air traveling through a duct system, trying to make it to the farthest room in the home, and that basement is, say, 50 degrees, you're probably losing the heat to the basement before it ever has a chance of making it into the conditioned space. This fact is so overlooked. For those of you that are doing heat pump retrofits, I'll tell you, this piece is the heat pump killer, especially when you're doing a retrofit from gas to heat pump. I have seen this, I have lived it, I've dealt with angry customers because of it. Because we go in, we install this on the exact same duct system, we inherited it because we weren't doing due diligence measuring. And now you have a piece of equipment in there with a much lower temperature rise. Sometimes that gas furnace, it was okay. If you're running, a 55-degree rise, now you've got a piece of equipment with a 25 to 30-degree rise, depending on outdoor ambient temperatures. And all of a sudden the customer's uncomfortable because that delta T, that temperature difference between the air coming out of the equipment and the air at the farthest grill or farthest supply register now is that much more crucial. And oftentimes we don't account for that. You can measure this. If you've got two wireless psychrometer probes, stick one at the discharge of the furnace or air handler and stick one at the farthest supply register or the most uncomfortable room in the home. See what your temperature difference is. Bare metal ducts, and sometimes even the choice of insulation. So there are manufacturers of insulation out there that tout very high R values. Measure them and see what they come up with, because you won't know until you start to test it. So you see how these things build upon one another. Each of these principles, they're building. We've got pressure that we're measuring at the equipment, down the ducts. We've got airflow that we're measuring at the equipment, at the ducts. You see how this is a complete approach, because this is where we're getting to making sure that those systems aren't low performance, but they're high performance. And you may say, this is too much. Well, we'll look at what you can pick and choose and apply here very shortly. So we're almost done. And that's where we get into the heat side. That's the BTUs. BTUs are a combination of airflow and temperature or enthalpy, depending on which stage you're in. When we start looking at sensible heat, which is a change in temperature that you can feel, that is airflow combined with the temperature difference across the equipment. So you can measure this and you can see how close that piece of equipment is operating when compared to what it's rated to do in a laboratory environment. And many times it's shocking what you'll find. That 57%. You'll see a piece of equipment that may be rated for 30,000 BTUs, only delivering 20,000 because of a whole host of these other parameters being out of line. So it's just something to keep in mind as you look at the BTUs. That is where the rubber meets the road on any HVAC system, and that is performance. If you've got BTUs, you have comfort, that is performance. I've been talking a lot, you guys. So notice we always go back to the equipment first. This is what everybody is comfortable with and where we think HVAC starts. The natural progression for this is we then move out into the system every single time. We make sure that those BTUs are delivered into the conditioned space. And here's what's cool. If you make sure that the airflow's there and you make sure that the temperature's there, the BTUs automatically happen because it's a calculation. Pretty neat, huh? If you've got airflow and you've got temperature, you've got performance. So it's just something to think about as you look into this. Now, taking those 4 acronyms, there's different ways that you can apply them. The first is the equipment itself. And as we work with contractors across the country, we recommend you start with what you're familiar with. Meet people where they're at. Most technicians, installers, equipment all day long. Great. If you're going to start becoming a high performance contractor and applying high performance HVAC principles, start at the box. Start at the equipment. Make sure that the pressures are within manufacturer specifications. Now, that doesn't mean that the ducts, you have to have everything right to get it at the equipment. Make sure your airflow is within manufacturer specifications, plus or minus 10% of what's required. If you're a commercial contractor and you have outside air being pulled into the equipment through like a economizer, making sure that it's within 10% of whatever the design ventilation requirements are. If you're looking at the temperature, make sure that it's within the temperature rise range of the equipment for those conditions that it's being tested at. And then of course the BTUs will naturally be delivered. You can take the BTUs that are delivered from the equipment and you can compare that to the manufacturer's extended performance data and see how close you are. If you're within 10% of the rated BTU output at those conditions, you're doing great. However, if you aren't, that's when the fun begins, because now you have to figure out where. And this is why targets are so important as we look at this path. There's all kinds of obstacles on a roadway that you may run over and puncture tires. You're going to find this with HVAC equipment as well. Sometimes those obstacles that can actually derail us and puncture our tires as we're trying to move along are internal practices when it comes to installation, design, communication, setting expectations with the customer, and then commissioning the equipment. So many times commissioning is skipped. We become so confident in our design and how we do things that we arrogantly skip the commissioning side because we assume it's going to operate. And that's when the downfall happens. That's when we run over the nail, and that's when we run off the road. So if you're skipping commissioning, there's incredible tools out there that make it easier than ever before. Bluetooth test instruments, smart probes. For those of you that are using MeasureQuick, I don't have to tell you how cool it is to see everything at once and to quantify that performance. So there are tools out there that make life easier than they ever have before, where many times we used to have to do these measurements manually. Now they're done automatically. So kind of excuses are gone. So first, we start at the equipment. Make sure your systems are operating within manufacturer specifications, delivering the right amount of BTUs. Next, we move into the system. We make sure that the duct system is doing what it's supposed to do, that delivery route. Many contractors, the first step that they'll use when they start transitioning into high performance HVAC is they simply start looking past the equipment into the ducts. And they start recognizing the opportunity that's there to better serve their customers, and also the horrendous workmanship that's there. How many on these calls have ever looked at a duct system and go, yeah, that's messed up? But then if you were asked how bad's it messed up, you're going to twiddle your thumbs, right? We know these things. We can look at a duct system and go, that's messed up. Measurements allow us to quantify the quality. They allow us to see just how bad it is from where it should be. Most systems, every return system is messed up. Maybe you can count on one hand how many return duct systems I've seen that don't need work. There's usually some type of a return repair that's needed. It's the most ignored part of the return ducts between supply and return. So start on the return. Typically, if there's an airflow problem, it's going to be on the return side. So pay very close attention to the return side of the system if you're trying to improve the performance of a system. The next side is the supply side. Airflow problems typically are on the return. Comfort side issues are typically on the supply. Now, this is not a hard rule. That's just experience speaking from doing this stuff for a long time. Comfort problems, look at the supply side. And there's other sides to this. You may have airflow and temperature from the supply registers, but remember, there's a second part of the duct system, and that's the building. So you see there's a progression to this. It took us 2 years to master pressure and airflow at our family company, and we weren't that large. We were less than 10 employees. So the larger your operation, the longer it may take you to scale this. If you're a smaller company, if there's only a few of you, you will be much more agile in how you're able to apply this. And then last is the building. And this is the one that kind of blows people away because they're like, that's not the HVAC system. That's not my responsibility. Oh, convince an uncomfortable customer that, even if it's not your fault, even if the HVAC system is doing everything it's supposed to do, if you're trying to condition a pathetic building, you will get the comfort complaints. No homeowner has ever called the insulation contractor and said, you didn't spray the foam incorrectly, this room's uncomfortable. They will always go to the HVAC professional. And that's why building science is a perfect connection for the HVAC industry, yet we continue to ignore it. If you are not looking at the building and how it affects the HVAC system, you are missing out on a lot. They are directly connected, whether we want to acknowledge it or not. The easiest way to start looking at the building is to start on the pressure side. Remember, we said the same principles apply. You can actually measure the static pressure of a building, but you have to use pascals. We mentioned this earlier. You can see what's happening room by room with pressures. If any of you dealt with humidity issues this past summer, there is a great possibility that you were fighting a building issue, not an HVAC issue. As we go into cooler temperatures, you guys probably have picked up on the twang in my voice. I'm from Central Kentucky. We just came out of single-digit negative teen wind chills, and a lot of houses got really dry around here. Not an HVAC issue. It was a building issue because you had super cold air infiltrating into the building, effectively acting as a dehumidifier. Many HVAC professionals got the call, not the building contractor. So tie in building pressures with what you're doing. It is amazing how it just changes because you're expanding from the building, from the equipment to the system to the building. Notice that your approach is broadening. Think of it this way. As you're driving down the road, instead of looking at one lane, now you're seeing the bigger picture the whole way. Remember, this is a journey. Some of you may choose not to see that broader path. That's okay. That's your choice. But just know it is out there and you can take advantage of it. So let's talk about some of the steps to this. We've covered a lot so far. We've covered the path to performance. We've covered what the problem was. Low performance. Don't inherit anybody's bad duct system. If you're doing heat pump retrofits, rule number 2, don't inherit somebody else's bad house. So there's a couple of rules there to consider. We talked about each of the principles that make those up. Pressure, airflow, temperature, and the end result is heat, or BTUs. We talked about 3 different ways that you could start to apply them. Now let's talk about the steps. You'll notice I'm big on acronyms. STEPS is actually an acronym as well. And that is how you start doing this stuff. And the first thing is you show. That's your first stop. You show that this stuff works. And you have to prove this to yourself. Remember earlier I mentioned that there were 3 parties that you have to convince of this and persuade. The first is you. You have to show yourself that this works. And you also have to show yourself that you need it. The biggest obstacle when we started doing this in our own family company was my dad. You may have heard this before. We've been doing this 30 years. There's nothing wrong with how we're doing things. Sound familiar? That was the mindset in our family company. And I kept challenging my dad. I was like, Dad, I really think there's things that we're not doing just right. So I had to show him. We got the test instruments. We started measuring. Remember, we couldn't afford these at the time. It was from a generous gift from a family member that we were able to get the test instruments. I showed him. We went out and we measured on a system that we designed according to industry standards, and then we measured. And half of our measurements were all over the place. We had some registers with twice the airflow, some with half. First thing we did was we blamed the capture hood. And then I called Rob Paul. He walked me through some other tests, and we validated the measurements that we took. I'll never forget, my dad looked up at me and he said, good Lord, what have we been doing all these years? It took him seeing it to show him the results to become a believer. Because if you don't believe in this and you don't care, you're not going to do it. It's too much work. But once you see it, that's where the change makes. The next part that you have to do is actually show it to the employees that you have, your staff. Your team needs to see the vision for this. Show them how it makes their work easier. It makes their lives more purposeful. If the only thing that they hear from you, if you start saying, we're going to measure static pressure and we're going to start measuring airflow, they're going to hear two words that will doom you before you ever start, and that's more work. If they hear more work, you're done before you ever start. Expect pushback, expect resistance. They're not going to do it. However, if they hear work easier, serve better, don't be surprised if they're going to run through a wall to get this done for you. They need to see your vision. They need to understand the purpose and why you're doing it. And then finally, your customers. You need to show them why you're different, why there's more to an HVAC system than just the equipment, as we've talked about. As you continue down that path, that's when we get into the T in steps, the teach part. It is an educational process. You will have to teach yourself. If you are not a lifelong learner, don't expect to grab this stuff, regardless of how much information's out there. There's a big difference between information, knowledge, and wisdom. One of the things that we like to think we do at NCI is we teach discernment, and that's how to apply the information and the knowledge that you have. That's wisdom. So you have to teach yourself. You've got to teach your staff how to do this. And as I said, this doesn't happen all at once. It's small. Small changes is what we're looking for. We're going to talk in a minute about something called 1 degree principle. Changes happen very slowly over time, either in the right way or the wrong way. And then you'll have to teach your customers. I will tell you that it makes talking to a customer that is angry so much fun, because now you're showing them it's not the equipment. There's other pieces that affect their comfort and the health of their home. So it changes the game, guys. And then finally, you need to equip them. This is part of the teaching step as well, but they need the test instruments. Some of the test instruments, as we talked about earlier, they're not cheap. So it will require commitment for you to equip your people. But first, you've got to equip yourself. Equip yourself for what you're going to be into. Equip yourself that many of the traditions that you've accepted as fact may be wrong. And you're going to have to deal with those. We did. We had to deal with our rules of thumb and the things that we weren't doing correctly, although we had been taught by people we respected for years that they were correct. Many times, daddy's duck sizing rules aren't the right way to do it. So you will have to equip yourself, both mentally and physically, with the right tools to do it. And then finally, promote. You can be the greatest technical mind in the world, but if you don't sell this, you will be broke. The key is you monetize this to better serve your customers, differentiate yourself, and solve problems. Remember, I said no smoke and mirrors with this. It's reality. You're not going out and using any fancy sales techniques. You're not selling magic light bulbs or anything else like that. You're selling based off of what the measurements show. And as you do that, you're custom tailoring your solutions for that customer's needs. And you're meeting expectations and proving it through measurements. So you will have to promote yourself to your customers. The easiest way to start in-house. If you're an HVAC contractor, start with your maintenance. If you have maintenance agreements, start there. These people have a relationship with you. They trust you. Start there. Then you can start moving into emergency calls and then start going out and saving the world. You have to teach yourself how to do this first, because one of the things that you may find is that your HVAC community needs saving from you. If you're not measuring, you don't know. So just keep that in mind. It's a hard pill to swallow. And this is where we get into small changes. If you look at a block of ice, there's still energy there. There's still heat energy. It's just not a lot of it, and it's not moving much. However, once you start to add heat to it, the temperature slowly rises. And what happens is you start to see a change in state. And this 1 degree principle says that if you continue to add heat, the BTUs will continue to go up, but eventually you hit a breaking point. In atmospheric conditions for water, that's 212 degrees. Once you hit that point, all of a sudden there's a massive amount of energy that was hidden inside that water that's released. It's what drives locomotives. It's what powers boilers. So when you look at this, it was hidden all along, but you have to keep pushing until you hit that point. Many in our industry will dip their toe in the water of high performance HVAC. They don't continue long enough to hit that boiling point, to hit that point where all of a sudden, all that hard work that was being done, those struggles, just like at a snap of a finger, they start making sense. And all that potential was released. And then it's like you look back and you go, wow, isn't that something? Give yourself time. Different people raise different temperature levels at different speeds. You'll notice this among yourself, among your team. Different people progress differently. Give yourself time. Give yourself some grace. Be patient if you're going to do this. If you try to do everything at once, remember the example of the lion. He freezes up and he doesn't do anything. So, for those of you that are Dr. Phil fans, you can't change what you don't acknowledge. You can, right now, you're being given a choice. You can explore this, you can look into it, see how that it better serves you, your customers, or you can say, nah, it looks like too much work. That's your choice. You can't change what you don't acknowledge, though. Once you measure, then you've got two options. You can either ignore it or you can do something about it. I'm thankful 25 years ago we did something about it when we questioned it. You guys are being met at that same crossroads right now. You can choose to do something with this information or you can choose not to. I've tried to lay out a high-level blueprint. It's worked for thousands of HVAC professionals across the country, and it can work for you too. But it will take work and it will take dedication. So just to wrap up our session, we talked about what the problem was, low performance HVAC, typical in the country. And that is from Kentucky to Washington to New York to California. It's across the country. We talked about the path, pressure, airflow, temperature, and heat. If you want to apply this to your company, apply it in those steps. Don't try to do everything all at once. And then finally, we talked about steps, showing, teaching, equipping, and promoting. Those 4 steps are how you will start to monetize this to better serve your customers and you. Instead of a low price race to the bottom, you're climbing a mountain. It's going to take all of us doing this if we're going to elevate the HVAC industry to what it's capable of. So as I said, my name is David Richardson. I am with National Comfort Institute. We are a culture change company. We do HVAC training. We're located in the Smoky Mountains of Tennessee. And guys, there's a website there if you want to check it out. Also, if you've got your phones, we do have a free magazine that you can subscribe to. If you want to snap that QR code, it's free. We talk about this stuff every month. There's articles that I've written. A lot of other great people have written, people you're probably familiar with. Some of you on this call may have even written some of them. I don't know. But it's free. You don't even have to pay for it. So sign up. I would encourage you to check it out. It focuses on that high performance mentality of doing the right thing, caring, proving it, showing that you do the best instead of just talking about it. So that is the path to high performance. Thank you all for attending. As we're going to open it up and see if we've got any questions.
All right. Thank you, David. That was a great presentation. I just want to make sure everybody knows, find the little questions icon somewhere on the toolbar of your screen and click on that, and we'll get your questions to David while I, wait a few minutes for people to get those rolling in. David, I loved the underlying theme of that presentation, which is lifelong learning. I think a lot of us, regardless of where we're at um, career-wise, we get kind of set into this is how things work, and we don't go to school anymore. And we're not necessarily aware that things have changed in our industry. Um, so I love that you challenged your dad, and that's tough on its own. And to his credit, he saw what you had to show him and turned your company around. I love that. Okay. Robert has a question from Clear Result, and I was thinking this myself, Robert. It says, great presentation. Shouldn't high performance HVAC start with the building envelope first? Um, and that is in your path.
Mhm.
So why did you decide to put building at the end, start with the equipment?
Because of the audience that we're aiming this for.
Yeah.
That's one of the reasons that home performance and building science have not taken into the HVAC industry, is because we have failed to connect it with what they do. We immediately throw building at them and they're like, why should I care? That doesn't meet them where they're at. So by taking this approach, it meets them where they're at and expands it out and causes them to look at things differently. It's one of the reasons why we face an uphill battle on getting contractors to do load calculations. And we sit back, we'll badmouth them for being lazy, incompetent, or whatever. And in reality, they just don't see the value in it. But by meeting them where they're at, then they start to see, oh, wait a minute, I need to be doing this. And that's why we put it at the end. Now, I will tell you from personal experience, I mentioned I was on my way out of the HVAC industry. One of the silver bullets that I was told that would save it, and we invested a lot of money in, was a blower door. We focused in the mid 90s on sealing up ducts and doing blower door tests. We pulled it out on every sales call, and customers were trying to kick us out of the house because they paid for they didn't pay, they expected an HVAC company to come in. And all of a sudden we're talking about insulation and air leaks, and it looked like a bait and switch. But when we flipped that and we started talking about it from an HVAC standpoint first, then we started to connect to the building, they understood. So the principle is true. It's the presentation that sometimes we get reversed. And that's why I started with HVAC, because I know it works.
Oh yeah, that
So
excuse
fantastic
me.
question. Thank you for that, Robert.
Yeah, that's a great answer too. Great insight into knowing your audience. Um, oh, Doug would like the QR code back on the screen if you want to
I
navigate
can
back.
do that.
Thank you, Doug.
Sorry, Doug. I moved a little too fast. There you go. Those are the two founders of NCI on the screen, by the way,
Oh,
if
nice.
you're wondering who that is. Rob Falk and Dominic Guarino. Rob, unfortunately, is no longer with us. COVID took him from us.
Oh. And we have another question from a different Robert. Where did you learn about making the pressure measurements you showed your dad?
Actually, through National Comfort Institute training. I learned through reading articles from Rob Falk in Contracting Business Magazine. That was one of the things that he would share, was static pressure measurement. So we started with that, and then we got into a class and learned how to do all this stuff. And it was air testing and diagnostics, I think, was the class that we originally went through back in 2000. So it took us, I think we went through a 2-day class, which is just where we kind of learned how to ride a bike with training wheels. And then once we got out into the field, that was where we took the training wheels off and really started learning it.
Oh, right, yeah. And uh, just you talking about the instrumentation stuff, I just want to make a plug for people in our area. The Smart Buildings Center has a tool lending library, and they have all of these tools that you can
That's
get on
great.
loan. So you don't have to cross your fingers that a family member is going to give you a gift. You can test these out, see if you want to invest in them for your company, or at least even just see how they work, if this isn't your profession. I'm gonna give a couple more minutes. That's it for questions so far, but I'm gonna give a couple more minutes for this, for
Okay.
people
Can I
to.
expand on the comment you just made about the tool library?
Heck yeah.
What an incredible resource. There's
Hmm.
only one other provider across the country that I know of that does that. If you guys are on this and it's local to your area, take advantage of that, because that gives you an opportunity to kick the tires and try it out without, taking that risk and that big investment up front.
Yep.
So thank you for mentioning that.
Yep, yep. It's a pretty cool resource that we've got, and that's right here in Seattle. But they will lend to the whole, well, whoever can physically get to it. But they don't have any, come down from Bellingham or come up from Portland if you're willing to make that drive.
That's great.
Aaron from Snowpud has a question. Welcome, fellow utility member. How has inverter variable speed equipment affected path, if at all?
That is a great question, because with single stage and multi-stage equipment, it was a lot easier to nail that down. With inverter-based equipment, the target's always moving. So you have to lock it into a single stage to nail that performance down. So it has changed it a little bit. The principles still apply, but you have to see what it's going to be in its test mode. Colleague of mine, his name's Adam Muffich, has said that an improperly sized inverter is the most expensive single stage you'll ever buy. So he's very cognizant of the inverter base, but what it does is it changes the targets because they're constantly moving. So you have to take that moving target and you got to make it come stationary. Great question. It has actually gotten more with the equipment. It's if I could take this a little bit farther to expand on it, a lot of times I say our industry because I still consider myself from the HVAC profession, we'll say that equipment's not the way that it used to be. It's it's not, it's junk and whatever other type of excuses that we make, and it's not the same that it used to be. Equipment of past days would tolerate much more slop. The equipment today is much more precise, and it's one of the reasons why we really have to nail things down and why I think high performance is more fitting today than it's ever been. So the slop that we used to allow for and that the equipment would kind of limp along through, today it won't. Anyone who has ever chased a blower motor failure fault or an error code knows this, and that pressure is one of the first steps to diagnosing that. Thank you for the inverter question. That was a great one.
And Robert asked if I could provide information on the tool library. I just pasted the link to that in the chat. So the the icon that doesn't have the question mark, it's two speech bubbles. If you go there, I put the link right in there. But John had a question. Do you have any recommendations for minimizing electric resistance auxiliary heat use? I'm assuming for heat pump installation.
Yes. Number one, make sure of course, the equipment has to be set up and charged correctly, both airflow and refrigerant charge. Number two, get as much insulation on those ducts as you can. Make sure that the same temperature air that is leaving the air handler is as close to possible to the air temperature coming out of the registers. Two, this is where we get back into the original statement. I believe it was Robert who made it about the building. Reduce the load. That is one of the biggest obstacles I see for heat pumps, is not just the HVAC installation, but trying to condition a building that's more connected to the outdoors than it is to the indoors. And so look for ways to reduce the load in the building. And I think this is why it all works together. It's not one or the other. It's a perfect match. So number one, make sure that the HVAC system is doing everything that it can to get that same temperature and volume of air at the registers. And then number two, make sure you're reducing the load as much as possible within that homeowner's budgets or expectations.
And actually, excuse me, that makes me think of another question. So when, say you do find some weatherization issues that could be addressed, do you think it's prudent for HVAC companies to kind of partner with a weatherization company, have an on-call weatherization company, or how do you
I think
address
it
that?
do. I think so. That's how we handled it. We did not do the work in-house unless it was something very small or simple. If it was a lot of work that we saw, and of course, remember, this is the homeowner's problem, not yours. We would make them aware that for us, our HVAC system to work correctly, this, and this has to be in place. And this is who we work with. And it's a fantastic opportunity to cross market with other skilled professionals, both coming and going. So absolutely. Some companies will actually bring this in-house, though. They have their own home performance divisions, and they will take care of that. So a lot of it is also going to be on how you set your company up. So that is going to be a matter of personal preference.
And I would imagine that kind of extends to commercial too, as we're doing a whole bunch of electrification retrofits in our city. We've got a mandate for building electrification. And I think these old buildings are going to find that they're going to have some envelope stuff to address before they can get their systems properly sized.
I guarantee it. It's the one thing that guys tend to really get is to think of a building like a Yeti cooler. And if you make the building like a Yeti cooler, That's the goal.
Yep,
That's the goal. With
I like
controlled
that.
ventilation, by the way. But
Yep.
that's what we're trying to get instead of taking an old styrofoam cooler and punching a hole in the side of it. So when you start talking coolers and beer, people all of a sudden start to get the relationships.
Love it. Okay, well, everybody, we are at time. So, oh, Annette has a real quick question. Can you stay on for a second, David?
Sure.
Okay, let's ask this one question and then we can end for the day. Annette says, do you recommend any other resources for building science education for those that are new to that area?
I can tell you where I learned it. The internet, thank goodness, is such a wealth of information. I got my training at Southeast Institute in Atlanta, Georgia, and met Dr. Allison Bales down there. He was actually my HERS provider for a long time. But where I cut my teeth on this when I was starting to learn about the dust was it was a builder's guide from Joe Stiebrick. It was a mixed humid builder's guide, and I think EEBA published it. I don't know if they still even publish it, but my goodness, that book was a wealth of information. So if you're just starting, get the builder's guides from Joe Stiebrick. They're incredible resources. And then I'm sure there's other locations that may be closer. South Face was the closest for me where I got training, and those guys are incredible. And they were always up in the central Kentucky area as well. So if any of those guys are on the call, shout out to you guys.
Nice. And now for residential, I don't know for sure around here, but um, South Seattle Community College has, or South Seattle College has a building science degree, if you wanted to go that route. Oh, and was it the name? Was it Joe Siebert, like
Stiebrick.
S-E-I?
It's
Stiebrick.
a very unique spelling. I think it's, and I'll mess it up. I think it's Lstibrek, Building Science
Oh,
Corporation. You've got some incredible downloads for free, but Building Science Corporation.
thank you for spelling that. We never would have gotten it.
No, it's nothing. They're out of Massachusetts, but just an
Oh,
incredible
okay,
resource for building science information.
great. Okay. Thank you again so much for joining us all the way from across the country.
Thanks for
My
having me.
colleague Robert saw this presentation or a similar presentation and said, we have to get you. And I hope everybody enjoyed the presentation. Again, the little survey will pop up. You can tell us, bring back David in the comments if you want. And that does it for the Labs 2025 webinars. We will see you again in January, and Robert reminded me that we do have another one besides the uh, heat pump water heater one. We have a small commercial buildings coming up January 16th. Those are both available to register for at lightingdesignlab.com. Happy holidays, everyone. Happy New Year, and we will see you in 2026.
Thank you.
Thank you, David.